Hi there. This video is taken from my course AZ300 for Azure Architects. If you are interested in becoming an Azure Architect, Microsoft does have two exams on it, the AZ300 and AZ301. This video is from the 300 course. There's a link to that course in the description of the video. If you want to be notified anytime there's a new video that goes live on this channel, go ahead and hit that like button and hit the subscribe button, and you'll be notified anytime there's a new video for you to watch. Anyways, let's get into the video. So I wanted to start off this course with a bit of a baseline set. The problem with teaching through video or teaching even live online to a group is that I have no way of really knowing your individual level of experience and adapting the content to you specifically. And so whether you're at the beginning, the leftmost of this chart, where you're a beginner, you don't really have much experience with Azure or even with cloud computing, or you're a little bit farther along the way, maybe you have experience with AWS, but not with Azure. You understand the cloud concepts and what the benefits are, but you don't really have the specific skills working with PowerShell, working with the portal, etc. Or maybe you're far, midway down this line here, and you've even passed one of the existing associate level exams, be it the administrator or the developer. You work in some specific areas of Azure, but you don't have exposure to the entire broad set of services that Azure has. Or maybe even you're above that and you've been working with Azure for a couple of years and you've got a broad range of skills. You've just not taken the architect test yet, and you want to take a course like this to catch yourself up on all of the areas of Azure that you're not exposed to on your day-to-day. Well, I don't really have that way of adapting this course to you specifically, and that's just the reality of it. And so as we're going through this course, I want to start off sort of here. I sort of picked an area on this line about 25% down where I want everyone to get to at least this level of knowledge. And so this video is sort of an attempt to get you, if you watch this video and follow it, you'll at least get to where that spot is on the line. Now, if you're very far to the right, if you're already an intermediate, you've already passed an associate level exam, or you've been working with Azure for years, maybe this stuff is not great for you and you want to sort of put this on a faster speed. I know with video technology, we can set videos to a faster speed. And so you might want to go through this at 1.5x or faster, or maybe even skip it entirely. That's totally up to you. But basically, I want to get everybody from that leftmost spot on the beginner, at least into a novice level in a single video or set of videos here. And so it's a bit of a challenge, but we're going to push everyone at least a little bit more to the right. Now, I will say that this does not necessarily replace the Azure Fundamentals level exam. Okay, you're not going to watch the single video and then go off and get certified as a fundamentals level on Azure. It doesn't cover all of the topics on that exam, but this is basically, I don't know if it's equivalent, or this is basically where we're aiming at. We're going to get people into this general range here. So we're going to start off talking about cloud computing in general, not necessarily specifically Microsoft Azure, but what's the big deal? Why, maybe you've worked in IT for a little bit of a time. You've worked with servers, client server setups or hosting. What's the big deal with cloud computing? What's all the fuss about? So this is in my own words, but basically the big deal with cloud computing is that it gives you this ability to rent computing resources. And not just, you can rent a resource at Bluehost or any of the hosting providers, but it's available for your use within minutes. And you only pay for what you use, whether it's in time or in gigabytes or other measurement. And that cost can literally be pennies. You could literally get a computer, use it for a little bit, and end up paying 30 cents. And when that came out about 10 years ago, that was a revolutionary idea. Okay, so before cloud computing was available, or if you're using services other than cloud computing services, either you own the equipment, and so you go off and you get the server, and it's a massive upfront cost and time. It takes weeks to install the software and then get that into your own data center. Or you have to do a rent or a lease type of thing, which may be less upfront cost, but it's still, you end up signing a lease for 3 years or 4 years, and you still need to take a week to lease some equipment. Or if you go, let's talk about Bluehost and those shared hosting models. That's not necessarily reliable performance. You lose something in that shared environment where you lose control. Other customers have the ability to negatively impact you and things like that. And it's not necessarily, you still have the commitment issues. You still have the amount of time it takes and the loss of control. So I can remember a story not too long ago, maybe 5 or 6 years ago, working in an environment where we knew we needed to grow the environment. We had a project coming up. We needed a server, a dev server, testing server, production server. And so you go, IBM is the host, and you go and you say, well, we need a server. And they go off. It takes them 48 hours to come back with a quote. They go off and find the latest hardware prices. They put their own estimates around it, how long it's going to take them to get the machine, how long it's going to take them to set it up, how long it's going to take them to get it available within the environment. And it comes back with a $50,000 price tag for a single server. And I have to go to my boss and say, we need $50,000 for this project. He doesn't have the authorization to spend $50,000 just like that. So he has to go to the finance team and say, we need $50,000. The finance team goes, well, we got to talk to the client, blah, blah, blah. It takes weeks to make this decision. Finally, we get the approval, blah, blah, blah. And so that's the environment many corporations and enterprises are coming from. Okay. So to go into the cloud environment where you can literally have this idea, and then within 20 minutes have a server at your disposal, try something out, and then say, oh, that actually will do something differently, and then stopping that. It's revolutionary. Cloud computing, if you go in there, it's not just Windows servers, Linux servers. There are hundreds of unique services, machine learning and databases and storage, and we'll get into that in a few seconds here. So back then, 10, 12 years ago, this infrastructure as a service, this is what they call when you go and get a server in the cloud or networking in the cloud, that's infrastructure. Provided as a service. That was sort of like the idea that Amazon had. That was sort of revolutionary. Now let's talk about the different companies that are available in this space. Now, hopefully you've heard of these people before. Amazon Web Services, AWS, was the first mover. I think they're about 12 years old at the time of recording. And as of today, they're still the largest cloud provider. Many people think they have a huge lead in the space, and I'm going to show you in a second that their huge lead isn't actually that huge. Microsoft Azure started about 10 years ago and is the current number 2 provider of public cloud services. The gap has really shrunk. Microsoft was outgrowing Amazon for years, and so basically they've caught up in a lot of ways. Google, which is, you're surprised because Google was sort of into search and YouTube and ads, and they were famous for having millions of servers long before, Microsoft decided to get into cloud, and they are actually lagging behind when it comes to providing public cloud services, not only lagging behind in revenue in that particular part, but in their capabilities and in their offerings and their vision, etc. I always turn to this company called RightScale, who produces what's called the State of the Cloud Report every year. And it's always interesting when they come out with this. The last State of the Cloud Report for 2019 actually showed Amazon AWS losing 1% of what was called adoption in the enterprise. So if you look only at these Fortune 500 or these big enterprise-sized companies, they've actually lost a point of market share in there. Azure has continued to grow, and they grew 2% over 2018. Google, again, 1%. To fall up at 1% or increase 1%, that's pretty flat, really. We've got the other players. There's many different cloud providers, some of them not even listed, but we're talking about Teams, we're talking about Alibaba at 4%, etc. And so in the enterprise, we'll see that these 1, 2, and 3, Amazon AWS, Microsoft Azure, and Google Cloud Platform are really the 3 top cloud providers. And the other ones, even if their adoption rate or their market share isn't so far, they're really far behind in capability, according to many things, including Gartner Group. Now, you'll see also from those percentages that, Amazon is at 67% and Azure at 60%. Well, the whole thing adds up to over 200%. So multi-cloud is pretty common. You'll have companies that use Amazon for this particular project and use Azure for something else. They'll put their stuff in an S3 bucket and they'll run their virtual machines in Azure, different tools for different purposes. There are, it's also a protection strategy in case the prices on AWS get out of hand. You have them compete against each other, etc. Many different reasons for using multiple cloud options. Now, I'm trying to express my excitement about the cloud. I personally think that this has been an awesome revolution. I've been so thrilled and excited to be part of it in the last few years in terms of teaching Azure. But I also want to sort of put a stop and say, let's just, really, the cloud is great and I love it, but it's really just a computer. there is no cloud. It's just someone else's computer. So I'm going to continue to be excited about it. I'm going to continue to try to get you to get excited about Azure particularly. But, it's just, we're talking about computing here. So that's sort of an overview of sort of the really high level overview of the players and of what the cloud is. Let's get a little bit deeper, bring the plane down a little bit lower and talk about the overall benefits of cloud. So I started off this video talking about renting computing resources available in minutes, charged by the minute, costs you a few cents. This is sort of the thing that grabbed people's attention. And you really can create a server in just a few minutes. I'm going to pause the slides here and we're going to switch over to the Azure Portal. So what I'm going to do here is I'm going to pretend like we just had this idea that we need a virtual machine. We need a Windows server for some project. And so let's see how long it actually takes from the idea to getting one. So I hit the stopwatch start. Now I'm not going to basically teach you or talk about exactly what I'm doing here. We're just going to pretend like we just had this idea. So I'm going to call this new idea. In this course, we're obviously going to get into how to create a virtual machine and all the wonderful stuff around that. I'm going to pick a bit of a bigger machine. So we're going to get the D4 machine. We'll get a Windows 2016. To give it the administrator user ID and password. I'm going to want to RDP into that box. I'm going to skip all the other options. It's offering me this machine at 16 cents Canadian per hour. And if I just click create. So just to get to the point where I've ordered the machine, a minute and 15 seconds here, a minute and 20 seconds from the idea to go and make me a machine. Let's see how long it takes for Azure to actually make it. And I should say one of the cool features here is we can actually watch it in progress. So creating a virtual machine is not just, we just need a machine. We also need a network. We need an IP address, security group, and right now we're getting storage created. So, that's all the things that are involved in creating a VM. All right, so right around the 5-minute mark, it says my deployment is complete. I can sort of open it up and see that this has, in fact, done its work. Going to the resource within the portal, I'm going to minimize the menu here. We can see that we have a virtual machine running. It's given me a public IP address. And so theoretically, I can use RDP, the Windows Remote Desktop Protocol, to get access to this machine using this IP address and the ID and password that I gave it. So let's go back to the stopwatch here. So 5 minutes into it, and we have a machine for use. Now, as you know, the first time that you run a machine, it takes a few seconds to start. So let's go into the connect button, click the RDP file. The RDP file comes to my local. I click connect. Remember, I created a specific account for this. I set this when I created the VM. I'm going to say OK. I have to accept this certificate. And now RDP has started. And so now it's going to take a minute or two for Windows to configure itself. And I'm going to create a profile for myself. And we have to configure this for a particular role, etc. The server is just going to be empty. It's just as if you installed a brand new version of Windows on a server that you have direct access to. So at this point, there's not really useful until I make it do something. But the point is, within 6 minutes of deciding that I wanted a virtual machine, I am here looking at the home screen of this brand new machine. And it's in a second going to pop up with do you want your PC to be discoverable? Say no. It's going to pop up with the role manager here, and we can decide this is an IS machine or a file server or some other purpose for it. But yeah, basically this is just a demo of how quickly you can decide you want resources. Now, I briefly touched on this earlier, but basically I'm only going to be charged for usage here. So this machine is currently running, and it started off less than 10 minutes ago at this point. I could hit the stop button at this point, and Azure would shut down the instance and make it, release the IP address and make it no longer accessible to me. But then I could start it up again and it will restart. So Azure is basically going to only charge me for the seconds, or in this case, maybe 2 or 3 minutes that the instance was actually created and running, right? So it's actually fairly easy to clean this whole thing up. Let's go into the resource group and we can see there are 7 resources that were created as a result of my request, including the virtual hard disk, the C drive, essentially, network interface card, storage for the diagnostics, IP address and stuff. Well, let's say this idea, I did spend a couple hours on it. I was like, okay, well, we proved that's a viable idea, but we're done with this machine for now. I can quickly delete the resource group, the entire set of it. And just as soon as we had the idea, within 2 or 3 minutes, all charges will stop, all the resources will get cleaned up, and we will have no lingering costs associated with this. So deleting and stopping the resource is just as easy as it was to create it. So in fact, the power here is there's no contract. I didn't sign a 3-year deal to get that machine, and no contact. I didn't have to call anybody. I didn't have to fill out a form and wait for someone to call me back. I didn't even have to file a ticket. I just went and created a resource, used it and deleted it, and not another human other than the bunch of you that are watching this video. Nobody else in the world knows that I did this. Let's talk about costs for a second. So not only is it the flexibility of creating these machines, we're literally talking about pennies per hour at this level. So I chose this from the pricing table, but a D level machine, D2 with 2 CPUs and 8 gigabits of RAM is 3.7 cents per hour. And that includes, this is a Linux machine, so there's no operating system cost. And in this particular case, we did need to, we'll talk about reserved instances later in this course for cost saving purposes, but this is, sort of an option of what's available out there. I would pay 10 cents an hour. So if I just created a machine like this, it's 10 cents an hour charged by the minute. And so 10 cents an hour charged by the minute really is about, 1/3 of a cent per minute, something like that. And we used that machine just now for about 4 minutes. And so maybe I just had about a 1.2 cents of cost for what I just demonstrated to you. Now, I've been talking about virtual machines, and that's certainly how, AWS and then Azure started in that infrastructure as a service space. But the innovation has not stopped. And basically, there are so many new ways of executing your code in the cloud. You don't need to have a Windows or a Linux server and then do all the installations and do the deployments manually and all of this, the old days stuff. So now we have all these different computing services. So we talked about virtual machines. We have operating system choices. Azure has something called web apps, which you just zip up your code, package it, configurations, and send it up to Azure, and they will run it. You don't have control over the hardware. You can choose performance tiers based on certain values, but you don't get to choose 2 CPUs, 8 gigabits of RAM, all this stuff. It's not a server model. And then to go what they've been calling serverless or functions as a service, you can actually just create your code right in the browser. You go into the portal, we'll demonstrate that at some point in this course, and write some lines of code, hit save, and from that point forward, Azure will execute your code whenever it's triggered. So functions are something that's good for not even worrying about development on your machine. It's just a small piece of code. Logic apps, these are workflow apps. It very much reminds me of Windows Workflow Services or SQL Server integration services and those types of no-code models, boxes and lines, drag and drop, connect things together, events that fire, trigger something else, etc. There's also Service Fabric. This is not a super popular way of doing coding, but if you want to break your big monolithic applications into dozens of small little services, Azure has some abilities to automatically manage, heal, monitoring and reporting and all that wonderful stuff onto these microservices and scaling. Containers are taking over the world. Microsoft has really embraced containers in a big way. Used to be Azure Container Services, and they moved to the Kubernetes standard, so as Azure Kubernetes Services, AKS. But it's not just having nodes and clusters and orchestrators. You can also have containers in web apps. You can have containers in Service Fabric. You can have container instances, which just we'll do a demo in a second, but we can get code running in a container in literally seconds. I demonstrated a virtual machine that took about 8 minutes to get started. If you want to beat that time, deploy code into a brand new container, and it can be done very quickly. We even have batching services where you've got jobs that have got millions of parallel tasks, and we can scale up some machines in that kind of metaphor. And that's just the compute, right? That's just the executing code in the cloud elements. The stuff that the cloud can do goes way beyond just compute. We're talking about databases, many, many different types of databases for all the different needs out there. We're talking about not even data, but storage, right? Files and backup files and websites and things like that. Networking services includes some security in there, like firewalls and things like that, load balancers. Machine learning is a big growth path, and Microsoft has these cognitive services that they offer if you want, text to speech and speech to text and image recognition and all of these wonderful things, chatbots. That's all in the machine learning category. Event hubs and queues, depending on your application communication style. Then on the right, we've got everything from identity and security elements, analytics, blockchain, if that's something that excites you. So all of these services are things that you can go into the cloud today and rent by the hour, by the event, by the execution, etc. So really cheap, relatively cheap services that you can't even duplicate this in your own data center without a lot of custom code, a lot of installations and stuff like that. So talking about containers, let's quickly create a container and show you how quickly that can go. All right, we're going to start up our stopwatch again. And this time we're going to use the command line instead of the user interface that we did for the virtual machine. Once again, I'm going to create a resource group. Now again, the purpose is not to teach you how to do this, but to show you how easy it is to do. So this is an empty resource group where we're going to create our resources. And I'm going to run a command here that creates a container, a Windows operating system container, and grabs an image from Docker Hub. So this is a Docker Hub URL for Microsoft Windows IIS. And we'll let that run. It's going to take a minute or so, but it's going to basically create a container running IIS. And we're going to see very quickly, hopefully, that, familiar screen, that's the first screen of IIS. When IIS successfully installs and there's no applications installed, we're going to see that sample app. So we'll give that a second. All right, so we see that within about 4 minutes time here, we have succeeded. And so I should be able to go to this URL, which I labeled it AZSGD demo, and we have the sort of default home screen for IIS when it's just first installed. And that's running in a container. And that took about 4 minutes, as we saw. So certainly Linux containers, the great thing about containers is that you can package up your code. Like say you've got your own application, IIS with your own websites, your own folders, everything all installed, and it takes the same amount of time to deploy. So because it's created as an image sitting in Docker repository, Docker Hub, and you deploy it to container and you've got it running. Now, I wouldn't necessarily recommend the ACI that we just demonstrated as a production instance because it's a solo instance here. There's no multiple nodes running. There's no fault tolerance, etc. So we'll get into Azure Kubernetes Service and stuff in future modules of this course. But to get code running, you can do that in 4 minutes, 5 minutes. It's got a public IP address. Even this one has a fully qualified domain name. And so if you've got to demonstrate some code, deploy some code, super quick, super reliable, stuff like that. Deleting it, so let's say we didn't want it anymore. AZ container delete, give it its name. I called it demo container. I say yes. And look at that, it returns in less than a second here. So deleting things, creating things can be very quick in the cloud. So let's get back to this sort of high-level overview of Microsoft Azure, of cloud computing. We've seen how powerful it can be. Microsoft Azure first came out in February 2010 to the public as Windows Azure, and in 2014 it was renamed to Microsoft Azure. 54 regions around the world, and that is the most of any cloud provider. So comparing, even AWS might have bigger revenue, and a little bit bigger market share. Azure has sort of established the investments in the buildings and the wires and the computers and the locations, exceeding even Azure in that respect. They've got data centers and regions in India, the Arab Emirates, and even in South Africa. We can grab this map. Microsoft has the Azure Regions page on his website, and it's always updated. There's always being regions being announced. So those 54 regions means that it is sort of looks pretty well spread over the globe. Of course, there's concentrations in North America, concentrations in Western Europe, Asia, but it's starting to establish itself more in places like Australia. We saw the Indian and UAE. There's a single region in Brazil, and I'm sure that's going to grow. And South Africa was a recent announcement too. So these are all sort of growing over time, and that's a lot of investment there. Now, you might see that number 54 and you think, wow, I'm going to go into Azure and I'm going to create a server in, imagine, a region. Not all regions are available to all customers. So there is the public cloud. So we'll be talking about the public cloud mostly in this course. But let's not forget there are 3 individual government clouds for the US. The German government has its own, not the German government, the German population has its own cloud for German citizens and other restricted regions. We'll talk about these terms. You might hear public and private and hybrid when it comes to cloud. Public cloud essentially means it's available to anyone. Anyone with a credit card can just sign up, maybe even takes a few minutes to create an account. Out of those 54 regions that I talked about, 28 of them are available for anyone to create. There are some restrictions, an additional 6 regions that are technically public, but you can't just go and create a resource. You need to qualify. There are some minor differences between the regions. And so you might really want this really powerful GPU server and series CPU that has, GPU capabilities, and that might only be available in some regions. So depending on the type of resource you want, you may be restricted to some regions and not others. Generally, most content is available in all regions. One thing that happens with data is it becomes very sensitive as to where data is stored. And I noticed that Azure does a pretty good job of respecting national boundaries. And so if you're getting your data into Canada, the Canadian regions, well, the data stays in Canada. Data in France stays in France. Data in UK is basically stored and stays in UK, etc. So they do a pretty good job of respecting those national boundaries because the way that data travels over the world has become sensitive for certain industries. Now we're talking about the other cloud, it's the government cloud. They have their own URLs even, right? It's not the same as the Azure public cloud. 8 regions currently, and even within that, it's fractured between the US governments like the federal, state, and local, which goes into one, and it even has its own like defense network and the secret network, I guess, is for the spies. And so you can't just get a virtual machine in the public cloud connecting privately over Azure into a virtual machine in the government cloud. There is restrictions. There's completely separate networks, not connected in any way. Germany has one of the toughest data protection policies. There's even a data trustee. And when you're creating a machine or creating data, you're going to have certain subtle differences between that and regular Azure. And so it's considered its own cloud as well. There are 4 regions in Germany. Now you may have heard, so that was the public cloud, right? Anyone can sign up for those things. I mean, even the government, if you qualify, you're a state government or you work with them, you can sign up. Private cloud, those are clouds that do have those restrictions. So the Department of Defense, like you can't just get your credit card and sign up for a DoD cloud, right? So those things are private. You can even download what's called Azure Stack, install that on your own hardware within your own data centers. And you would have Azure effectively running within your own data center, and you can take advantage of those commands. I just showed you how to create a container. Well, you could do that on your own hardware in the same sort of manner with Azure Stack. I know that it's been introduced a few years ago and is slowly gaining some speed, and they're talking about re-architecting it now. So I wouldn't put a lot of investment into Azure Stack right now. It's definitely Microsoft's trying to find its place for it. You can also have, it's sometimes called the internal cloud or the corporate cloud. Like if it's a network that's just for the employees of your own company, that would be a private cloud. The other term you might hear is hybrid. And so that is the combination between some sort of public cloud and your own network. So it's used in a lot of places. Basically, it's a combination of your own private software, hardware, applications, and the public cloud. So you can have your primary data center in your own premises, and then if there's a disaster, you have the backup ready to go in the cloud in case of a disaster. So it's not used except in case of emergency. Your SQL Server has the extension option where you can push data from a local SQL Server into the cloud, take advantage of the cloud storage. There is the opposite where you can have Azure public services connecting to private services in your network through a gateway relay, any kind of mix and match between public and private. Now, I do want to just spend another moment talking about Microsoft's global network here. So, we just talked about the 54 regions and how all of these things are available to you in the public cloud to be able to create computing resources anywhere you want in the world effectively for pennies. But how is Microsoft able to do this? Well, over the years, they've invested billions and billions of dollars in these buildings and all this computers and the wiring and all that stuff. Here's a picture. A bit of a slideshow moment here, but here's a picture of a data center in Amsterdam. This is a Microsoft data center in Western Europe here. And you can see all the cooling units on top of it. So inside there are a couple of floors of servers. You go into it. This is in Wyoming here, but you go into it. It's a warehouse just full of servers. And Microsoft has standardized all this hardware. And so whenever they're installing servers and building brand new data centers, they just they know what they're doing. They're building it based on this plan. I saw this picture in my searches here of Microsoft Azure servers that are designed to run in the ocean floor. So this is off the coast of Scotland. They put some servers into this tube and they dip it into the water, plug in electricity and in networking. Now, the advantage of this type of thing is that it's a sealed container. There's no dust getting in there. There's no contaminants of any kind. There's no lights inside. And so those machines can actually just run. Should be no real hardware failures. There's nothing that can get in there that can damage the hardware. They're supposed to be more durable than a regular data center where people are coming and going. The other thing, too, is they can take advantage of the cold water for cooling purposes. So we don't need to run all those air conditioners on top of a building, and that costs money. It has cold water all around it. And so Microsoft is sort of innovating on these types of data centers. Now, the other thing is not just the buildings and the servers, but they've got their own fiber. And so this is not running on the public internet. Actually, Microsoft said, I think it's the largest or the second largest private network in the world. So these lines all represent fiber capacity that, as you can see on the west, all through North America, under the Pacific Ocean, under the Atlantic Ocean, all around Africa, all around Europe, and through Asia. And so these are high-speed, multi-terabyte, multi-petabyte traffics that can travel over the world. And so when Microsoft is dealing between their North American data centers and their European data centers, they're running on their own network. Not only, of course, is it costing them nothing to do that, but it's protected from the travels of AT&T and other providers who are running the public internet. So they're investing in this in many different ways that we don't get to see effectively. One of the things that I saw was they connect like Spain and Virginia for their data centers. Most transatlantic connections are between the UK and New York, right? So they're even protecting regional things in a slightly different way that you would think. So now let's switch it up a little bit and let's talk about the buzzwords effectively. You'll hear these things as being advantages or features of the cloud, and we're going to just sort of dive into some of these. Now, first concept is the economies of scale. Now, it's just a fact, I guess, that Microsoft can purchase a server, install it, and run it for cheaper than almost anyone else in the entire world, right? They're at that scale where they can run a server for a lot less than you can run a server, okay? This includes not only the purchase of the hardware, because they can go and negotiate. If they're going to go buy 100,000 servers from somebody, they're going to get a really great price that you're not going to be able to get. There was a slide that said they have electricity is about 20% of the cost of running a server on your own. And Microsoft's building data centers next to rivers, and they're being able to draw on the river to power their data center, etc. So all of these ways that Microsoft is getting electricity cheaply. There's certain countries, if you're any familiar with Bitcoin countries that are known as having cheaper electricity costs. And so Microsoft can install servers and get the absolute lowest rates on electricity. Even the labor costs. Now you might think, oh, Microsoft's employees are not any cheaper than my employees. Maybe they're more expensive, but you're only running 100 servers. Microsoft's employees are running hundreds of thousands of servers each. And so the cost per server, an employee can cost can be distributed over way too many servers. And the other thing you don't really think about on the demand side is the utilization of the servers. And so while you're running servers and you may have daytime and nighttime and certain capacities that go up and down, seasonal, Christmas time versus the summer seasons, Microsoft is able to, because of their global reach and the millions of customers, they're able to manage the demand nighttime, daytime, Christmas, winter, summer, because of the way that the world works. So they're able to get higher utilization rates out of their hardware and manage it than you would out of your hardware. So the first concept we'll talk about is the concept of high availability. Now, you may be familiar with this because it's not just a cloud concept, but it's a concept in general. The availability of a system is basically the percentage of time that whole application, like the thing as a whole, is able to successfully respond to user requests. And so you can use the word uptime as a very proxy or very similar word, but it's not just the uptime of that server. It's the connection to the internet. It's the backend services, the database that serves the server, the load balancers, and all of the services around it. So it is uptime, but it's not just uptime of a single machine. Now, you might think 90% is a high score, and if you pass your exams, your parents might be pretty proud of you with a 90% grade, but 90% availability in server is not that great. It's literally 2.5 hours of downtime per day. That means you are aiming to, be down from midnight to 3 a.m. every night, and that's not a really available server, right? If you radically scale that up and say, okay, we're going to go for 99% availability, that's still about 15 minutes a day of downtime. I mean, that's basically the time it takes to reboot a server. And so if you said the nature of our server, the nature of our application is that we need to reboot it every day. We cannot function more than a few days without a reboot. So every morning at 3 a.m., we're going to reboot the server. That's technically 99% availability because you can't keep that server running more than, with 15 minutes a day, it needs to be rebooted. So it's pretty good availability. Maybe your customers wouldn't necessarily notice, except if it's like every day in the middle of the day, unexpected, that would be a problem. Now we get to the concept of high availability. So that was just availability in general, but high availability is intentional, right? It's intentionally creating a system that seeks to avoid downtime. And that requires thought, right? That requires planning in advance. And it's not necessarily the cheapest solution. You're going to have to go for higher level, more expensive services from the cloud providers, including Azure. You're going to have to go for duplication, replication, backups, all of this stuff. It adds cost. So to get from, we were just on the last slide of 90 and 99%, now we're talking 99.9. And when we get into these nines, you might hear them referred to as 3 nines, 4 nines, 5 nines. So 3 nines availability is 1.5 minutes a day. And that's, that's actually pretty good. If your application isn't available from, just randomly from 3 o'clock to 3:01 p.m., you're not really people will deal with that. But that's not necessarily super ideal. We get to 4 nines availability. That's only seconds, right? That is 9 seconds per day. That's very difficult to achieve for 4 nines on a single server because servers need stuff installed. Servers need rebooting from time to time. When you get into 3 nines and 4 nines, you're talking about having multiple copies of your application in different regions, load balanced, etc. Now you might think, okay, my goal is to be 100% available. 100 is the goal. Well, that's sort of a mythical creature. It's like the Loch Ness Monster or a Yeti or something where, you could set that as a goal, I guess, but it's generally not entirely possible. And I say this very carefully because there are companies out there who are bigger than you and bigger than your client, like Facebook, like Google, like Amazon.com retail site, all of these companies who do not have 100% availability. I can remember just over a month and a half ago, Google search being down. I went to google.com and I got an error message. And you stop for a second and go, what am I seeing here? Google.com's not available. And then you refresh the browser and it comes back. but that's not 100%. If I get an error from google.com, even if it's just for a few seconds, that's down. And there are times too when we hear about these cloud providers having regional outages. And so Microsoft Azure will occasionally have a bad deployment. AWS will occasionally kill their whole region. And then you hear about these companies like Stripe and all of these e-commerce companies and eBays and things like that having outages because the cloud provider has an outage. And so it's 100% is generally thought to be impossible. And prove me wrong there, I guess. Next concept, we just thought, so that's a high availability. It's intentional, right? But you can't get to 100, but you can get 99, 99.99, 4 nines, 5 nines. Those are attainable. Scalability. Scalability is the ability of your system to handle the growth of the users or the growth of the work for those users. And we can take a graphic like this, really crude graphic that I drew, but you can see that every system has a max capacity. Every system, okay? Even Amazon.com has a max capacity, but Amazon.com sets their limits so high that it's higher than their usual spike in traffic, okay? I worked in an environment once where we did load testing and we, ran a load test against our main website. And then you come back and it says it can handle this many thousand concurrent users, and you find out where that bottleneck is. Is it, in the traffic to the database? Is it in the IO system writing files to the server? Is it CPU? Is it memory? What is the bottleneck? And then you work on that. You run the test again. It's a recurring process to say, what is your bottleneck? But every app has a bottleneck, every app. So scaling is not the act of being able to scale, but is it possible? Is it easy? Can you just add a server and boom, you've increased your capacity? So can you increase your capacity? That means no code changes, no refactoring of your code, no re-architecting of your solution. If you can grow your solution, then you can say your solution is scalable. And so a related concept to scaling is this concept of elasticity, right? You'll hear, especially with AWS, they tend to have everything's elastic. They have elastic databases and elastic computes and elastic storage. What is elastic, right? The elastic element is that the system can automatically grow and shrink based on the application's demand. So the rubber band aspect. And so we had that graph when we said about scaling, where we have a maximum capacity, where you have an increasing user demand over time and that failure point, okay? But if your application it was elastic, then the capacity can grow. And so as your demand grows, capacity raises to meet it, right? And then when the demand eventually shrinks, as it normally does, then the capacity shrinks back down. That is an elastic system, auto scaling. And you'll see the capacity is sort of staggered. It's got steps, not smooth. Because typically when you have 4 servers and then you add a 5th server, the growth in capacity is not smooth. You just increase your capacity 20%. And then you add a couple more servers, you've increased your capacity another 20%. So capacity tends to, come in bursts essentially. And so this elastic thing, the requirement for that is the system can detect when it's getting busy and add more resources when it is. And because we're in the cloud, it's cheaper. You'll end up saving a lot of money because your system is elastic. Now, it's important to understand where these failure points can happen, right? So when we're talking about availability and we're saying, why isn't it 100? Why can't you just install an application into a server and it runs? Why? Well, the thing is, we're living in the world of computers and hardware fails, right? You have a home computer. Sometimes your power supply dies. Sometimes your hard drive dies. Sometimes the memory goes wonky. That just happens. Hardware erodes over time. Those connections get a thing. There's a little bit of corrosion going on. Dust gets in there. Hardware fails. We live also in this world where, your regional elements are out of your control, right? There could be a storm, a flood, power outage. I'm old enough to remember when the whole east coast of the US and Canada were down, no electricity for a day. And, that stuff happens. And it's hard to keep your data center running when everything else around you is out of power, right? So your batteries only last for so long, and the gas and stuff lasts for so long. But if the internet's down, the internet's down. We also suffer internet outages where traffic starts to fail, packets are being dropped, routers have gone bad. It happens. Now, we're also at the mercy of these cloud providers for their own deployments and their own software, right? We're running our software, but they're also running their software. So it does happen that Microsoft Azure will deploy something to a region, and that was just some unexpected thing happened, a bad deployment. They have to roll it back. We don't forget we live in a world of security, and we have to patch Windows sometimes. We have to patch our software. Microsoft has to patch their own Azure operating system. Things need updates. And so that requires a reboot sometimes, and that requires a downtime. So downtime happens in a lot of unplanned ways and also even in planned ways, which are the updates. To get that high availability, if you want that 99.999%, what about your own code? What about your own app? How are you going to deploy version 2 of your app without taking down version 1? Well, there are technologies for that, like Service Fabric. You can deploy version 2 of something and it'll just switch over with no downtime for users. But that's something that's intentional, thoughtful, planned in advance. It's not by default. But how can you update the database, add a column, remove a column, change the structure of something while your application is still running? All those sorts of things. Don't forget, we live in a dangerous world where denial of service attacks are a thing. People can go to your application and send 1 million visits at the same time to it, and all of your infrastructure, even if you're elastic and scalable, gets overwhelmed. Your load balancer gets overwhelmed. The incoming stuff gets overwhelmed, and existing customers suffer. Also, just mistakes happen, right? You can accidentally check in some code that's not complete, missing a file, and hit that deployment switch, and suddenly you're on production. It's happened to all of us. It'll happen, continue to happen. I remember even with AWS happened once where somebody was entering a command line. They were trying to remove an item from a routing table, but they didn't specify the IP address range properly. They made a typo, if you will, hit enter, and the AWS engineer wiped out the routing table. And AWS Eastern Region was down for 6 hours because of a human error. It happens. So I'm trying to bring this home here. Azure goes down, AWS goes down, Google goes down. Every major cloud provider has their moments where they have some sort of operation. Hopefully not frequent, but you need to design your applications to keep running during these things. I guess if it's a priority to you, you need to. How do you design your app? If Azure Eastern Region goes down, how do your app continue to run? Well, there are ways to do that. I'm not going to cover that during this intro here. We're still in the intro section to this course, but attaining high availability, it's an architectural problem. There are solutions for it all the time. These companies, including Azure, coming out with improvements. So Azure Front Door Service was just released last couple of months. That's an improvement to the way that these things happen and can be managed on a regional level. Related to these things of scalability and keeping availability, keeping it running, what happens if it does go down, right? You got keeping it running on one side. The flip side of the same coin is being able to recover from failure. And the two questions that are the key questions for recovering is what's an acceptable amount of downtime? Okay, so let's say you're down for an hour and it was a disaster. Is that acceptable? And let's say it's not. Let's say you're like, no, we need to be up and running within 5 minutes. Well, how much data would you be willing to lose? To get that up and running in 5 minutes, you need to have your data backed up and stored in alternative locations and accessible from those locations. And so how often are you doing backups? Are you doing backups every 5 minutes? Are you doing backups constantly? Is it a constant synchronization? And so these things are part of disaster recovery. So I wanted to wrap up this introductory section here to talk about where we're at. Okay, so I started off this section talking about the continuum of knowledge, where you're starting from the beginning. You've got no knowledge, very little knowledge of what cloud computing is, what Azure is, and you can go all the way through to the expert level where you're ready to take and pass the exam, and you pass it with a great score, and even beyond, right? There's more to Azure than even beyond what is tested at the expert certification level. But I wanted to get people to sort of like a little bit farther down the continuum from the beginner level, at least into this novice level. Like I said, it wasn't my plan to get you to pass the fundamentals exam, but if you take what I just did and go and take an AZ900 course and go to take an AZ900 exam, you might be pretty far ready for that. But so hopefully we got a little bit farther down that continuum. Now I need to warn you, right? Azure is huge.
There is a lot to learn. You're going to feel overwhelmed by this. There are hundreds of videos to go through, and not even only that, but hundreds of topics and hundreds of services. If you look at the compute options that we reviewed, there are 8 or 10 different ways of executing code in Azure. Database options, there's 8 or 10 different database options. Storage options, networking options, load balancing options, how to achieve high availability, etc., 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 etc. So Azure is actually huge, and it's very difficult in any kind of course, to be honest, to convey expert level knowledge in hundreds of areas. So there is a lot. Now, think about what your job is. If your job is to become an Azure architect and start designing solutions for Azure, well, then your job revolves around the question of why. Okay. We do need to understand all of the Azure options, all of the offerings. So there is this broad level of knowledge in terms of what is available, but why? Why would you choose out of those 10 compute options between web apps and VMs, of serverless model with functions and service fabric? Why would you choose one over the other? All of them have pros and cons. There are cost implications, there's performance implications, control implications, and the expert level knowledge required, etc. So all of these things have pros and cons, and our job as architects ultimately is to understand what's available and why you would choose one over the other. And so a lot of what we're going to be talking about is how does this work and why would you choose it? Now you'll find if you're interested in getting into the exams in terms of Azure architecture exams, that there are how elements to it. So it's not just why, right? So Microsoft is going to ask you to create a VM, not just understand why you would want to create a VM, but they're going to say, go ahead and do it. So we do need to go deeper than just the why. Also, I believe in terms of learning, this is going to help you. So doing is actually better than hearing. It's actually better than seeing someone do it, doing it yourself. And so my intention and my hope is that you're going to not in this section, but when we get into various talking about databases and virtual machines and web apps, that you're going to go and do it. You're going to say, oh, well, I'm going to go and try to create a web app and see how easy or how hard it was. Okay. So doing is better than seeing and listening when it comes to learning. I want to end with sort of with my approach. Okay. I'm not here to sort of preach at you, but I do want to encourage you. I want to encourage you to not be afraid of it. Don't be afraid of Azure. Don't be afraid to ask questions. Don't be afraid to look something up. Go do a search in your favorite search engine. Microsoft has a great docs website, documents. And so their help website is fantastic. Or try it yourself, right? You don't need to ask me to, what happens when you try to create 2 web apps with the same name? Well, go and create a web app and then create a second web app with the same name and see what happens. So that this is the great thing about Azure. It's cheap or free to do certain things, and you will see for yourself. And that's, I think, what you'll learn better than if I told you and I looked it up and I answered the question. So don't be afraid of Azure, and don't be afraid to go and explore with it and play with it and, expand your own understanding. My final philosophy, I put resourcefulness wins, and I'm going to put that on its own slide here. This is not just for Azure. It's not just for this course, but for every course you'll ever take. I think this is true for your career. I think this is true for anything. If you are presented with a problem, there are 2 types of people. If you're presented with a problem and you stop and you wait until someone comes along and helps you, that is less than ideal. Okay. You are not going to go as far as the person who's presented with a problem and solves it, goes around it, goes under it, goes through it, destroys it. Okay. So there's no brick wall. It's only in your mind. So resourcefulness wins, not only with this course, not only with Azure, but with everything. Now, that's hopefully the only preachiness part of this whole thing. But I want to encourage you to be resourceful and to not let anything stop you. If I have a video coming up and it doesn't quite get into enough detail from something that you're really interested in, don't let that stop you. Go find it and go deeper. Okay. Resourcefulness wins. Thanks.
Thank you so much for checking out this video that was taken from my course for AZ300 Azure Architecture Technologies. Again, to get Azure Architect certified, there are 2 exams, the AZ300 and AZ301. If you are interested in training on Azure Architecture, there's a link to my course that's in the description for this video. If you want to be notified when there's a new video that goes live for free, go ahead and hit the like button, hit the subscribe button, make sure you are in that to get notifications. I want to thank you so much for checking out this video. I hope it was helpful to you, and I hope to see you again.